Good morning, my name is Gabriele Grea and I represent Redmint Impresa Sociale, partner of the CE4CE project. In this presentation, I will introduce you to the life cycle approach to rolling stock planning. In this presentation, we will talk about why circularity in rolling stocks, how to measure sustainability and performance, where do we stand in circularity, and the approaches to advancing circularity in public transport rolling stock life cycle. Why a circular economy approach in public transport rolling stock? First of all, to minimize the negative external impacts generated by the material and energy-intensive production, use, and decommissioning of rolling stock. Secondly, because it generates returns in terms of resource efficiency through the extension of the lifespan of rolling stock, the rational planning of operations, maintenance and repair activities, and the possibility of repurposing and reusing vehicles and especially key components such as batteries. How can we assess the performance in terms of circularity? A first approach to ensure that sustainability and circularity processes are adequately fulfilled by the rolling stock suppliers is represented by the compliance analysis with industrial standards. The procurement process should include references to relevant ISO standards to ensure compliance with industry best practices. LCA methodology can be used to assess the environmental impact of rolling stock across its entire lifespan, considering all processes involved from the extraction of raw materials to the manufacturing, production phase, operations, use phase, and end of life. Environmental Product Declarations, EPD, provide condensed, transparent, and comparable information on the environmental impact of a product or service. The EPD is an independently verified document compiled and reviewed by an independent certified body. By presenting the results of an LCA study in an EPD, manufacturers can provide clear and concise information to customers and other stakeholders about the environmental impact of the products or services. The Circularity Compass framework will guide us through the classification of circular practices across production, operations, and end-of-life phases of public transport. The avoid stage is particularly central to the planning and design of circular practices in the production phase and refers to the strategic choices in raw and intermediate materials and energy sources to be provided to the process. The reduction of materials used in the construction phase represents a practical example of actions that can be fostered by procurement practices and proven through a life cycle assessment. Another element to be considered regarding the use phase is related to the optimization of operations through the use of route planning algorithms and eco-driving technologies and behaviors to reduce energy consumption. But the main contribution to the avoid stage concerning rolling stock remained indeed focused on the construction phase. Another important example is represented by the development of modular components for vehicles, reducing lifetime's material demand, facilitating easier maintenance, repair, and replacement of parts. The extend stage is focusing on particular on the use or operational phase of the rolling stock, but also to the end of life of their components, in particular the batteries. When it comes to electrification of the fleets, the lifetime of vehicles and batteries can be different, depending on the use of the rolling stock. Battery refurbishments extend the usable life of a vehicle by 7 to 8 years, improving its sustainability by generating environmental as well as economic savings. Furthermore, the life of batteries can be prolonged by extension of warranties, labeling, and access to operational battery data in order to improve monitoring, optimization of use, and repair. Predictive maintenance can increase the rolling stock lifespan, reducing the time for extraordinary interventions and consequent downtime of vehicles, and optimizing the use of resources while performing maintenance operations. The transform stage finds its main application in the end-of-life phase, when rolling stock and its components are not suitable for operations, and vehicles and components themselves can be reused for different purposes or recycled. Central to this process is the role of batteries. As main critical components in the decarbonization and electrification of public transport, their use and recycling opportunity represents a game changer for the sustainability of electric fleets. The lifespan of a battery when reused in stationary applications can be extended beyond the traditional utility in vehicles. This happens not only within the framework of public transport operations, but as the availability of batteries not anymore suitable for operations grows, typically after 6 to 8 years, depending on the mileage, options as the application in electricity grids, building, and industry are becoming more relevant. Recycling is the process of recovering raw materials as possible from batteries through a careful process that prevents fire and contamination. Batteries are composed by lithium, nickel, cobalt, copper, and manganese. Fractions such as polymers, aluminium, copper, black mass can be sold as industrial raw materials or used for the production of new batteries. It has been estimated that the primary metal consumption for batteries can be reduced by 25% for the lithium, 55% to the copper in 2040 thanks to recycling, improving technologies, and reusing of raw materials, of recycled materials. The enable approach can be considered cross-cutting with respect to the productions, operations, and use and end-of-life phases, and comprises all those activities creating conditions for circularity practices to be implemented, including regulation, planning, funding, and procurement. Policy measures can create a framework for the integration of circularity requirement into procurement processes by adapting to EU regulations and innovating. Procurement can improve the impact of circularity not only by following regulatory prescriptions, but also innovating, for example, exploring the synergies between rolling stocks, infrastructure, and energy resources. Looking at the state-of-the-art of circularity in public transport, the first aspect is represented by the supply chain potential. If the role of buses and battery manufacturers is clear and connected with technological development of vehicle manufacturing sector, on the other side, part of the unexpressed potential lays in other sections of the chain. In some cases, the limits to circularity are related to the size of the supplier companies. Smaller suppliers do not have the financial or innovation capacity to invest and make the production more circular, from the installation of photovoltaic to the acquisition of duty vehicles, the use of sustainable materials, and so on. For other types of suppliers, there can be a trade-off between the avoiding the use of harmful substances and the lifespan of their applications, such as paint production, and therefore between the avoid and the extend approaches. On the other side, some suppliers are already focused on circular solutions. The production and use of reconstructed tires, for example, is an established practice that minimizes the use of primary materials. Awareness and acceptance of new circular solutions has emerged as a barrier to the successful implementation along the supply chain as well. Life cycle assessment is there, but its adoption is still scattered, although its range of application could be broadened. Circularity assessments has several linkages with company accounting practices, economic sustainability, ESG, and it can highlight a broad range of internal and external benefits and savings. From the supply side, an important aspect is the progressive adoption of eco-design approaches to ensure not only that the final solution is compliant with sustainability and circularity paradigms, but also that the production process is optimized and cost-effective. The transmission towards zero-emission fleets provides a great opportunity for the modernization of public transport. At the same time, the system composed by vehicle, battery, and infrastructure must be fine-tuned in the investment process in order to optimize the exploitation of the available resources over a longer period of time. At the present stage, investments are not sufficiently aligned. Case history is usually not enough reliable to build a comprehensive investment strategy on, and technological development is fast in developing new solutions to replace the current ones. Planning according to the extent principles, although the technological choices made in the recent past might not be cutting edge, and the life cycle of the different components may not be aligned, is fundamental to ensure long-term sustainability to the ecological transition process. Revamping and overhaul of battery packs, upgrade of charging infrastructure, and to a certain extent also joint procurement and financing of vehicles and infrastructure are examples of how strategic planning can be successful. The level of complexity is rising as long as technologies overlap and different generations of solutions coexist. A comprehensive approach is necessary to ensure the extension of lifespan of the fleet according to circularity objectives. Product design plays a pivotal role in enabling transform stage of circularity, such as remanufacturing, refurbishing, and recycling. In rolling stock, for example, vehicles, modular transport equipment, manufacturing. This stage, in fact, focuses on converting end-of-life products or components into new value-added forms, and well-considered product design is essential for this transformation to be efficient, cost-effective, and sustainable. At the present stage, experiences of circular design in public transports are limited and focus mainly on components such as interior furnishing, refurbishing seats, etc. Innovative approaches to circular product design should focus in the future on the key components such as powertrains and batteries in order to allow their use in different contexts, extending their lifespan through alternative applications. A status quo analysis run here highlighted the presence of practices for battery reuse, which, within and outside the public transport framework, mainly at test or pilot level. In many cases, the ownership of the battery at the end of the life is not even clearly stated in the contracts. A systematic approach is needed. The traceability of batteries used in electric buses is advancing, but remains a work in progress as the industry seeks to enable efficient reuse and second life application. The core objective is to track the battery's history, usage, and conditions throughout its life cycle to facilitate safe and economically viable repurposing after its initial use in vehicles. At the enable stage, one of the emerging elements is the need for standardization of procedures and requirements related to the different stages of circularity, and especially production and transformation. Particularly important is the case of batteries, where standardization is fundamental for diagnosis, repairing, refurbishing, transforming in order to exploit them better and further during their second life and recycling. But more in general, the standardization of process across all the stages, production, operations, and end of life, is perceived as a necessary condition to create a valuable and durable impact within circularity practices. Enforcing EU regulations, not only at national but also at local level, emerged in the discussion as a common need for implementing circularity measures in public transport. In particular, the regulation on batteries, as for other components, should be received and applied in order to improve the reliability and reduce risks for public transport operators, in order to foster the broader application of new technologies. Green and circular procurement is the tool used by PTOs and PTAs to foster circularity along the supply chain, but there are challenges represented by the capacity of suppliers in generating benefits in a sustainable and competitive framework. For this reason, it is very important that the experience made so far become part of a strategic approach where in many cases elements of innovation in procurement include the possibility of purchasing rolling stock, infrastructure, and energy in different combinations in order to create conditions to extract value from the circularity process. Now, let me give some examples of approaches to advancing circularity in public transport rolling stock life cycle that you will find in the C4C strategy for circularity in rolling stock and on the circularityforpublictransport.eu website. Concerning redesign operations for a more energy-efficient solution, example is the digital twin e-corridor simulation in Gdynia to identify the most suitable routes for e-buses and trolleybuses. To reduce components' weight and size, fundamental is the use of lightweight composite materials. To reinforce circular green procurement, you can follow the establishing of quality requirements for e-buses as done in the city of Leipzig. At the extend stage, different good practices deal with the retrofitting of existing vehicle fleet, such as the city of Ankara in Turkey, where the second-hand diesel buses were converted into electric vehicles, or in India, where large-scale testing of bus prototypes in different cities allowed for more effective procurement strategies, or in the case of Paris RER B line, where refurbished rolling stock is currently largely deployed. Let's have a look at what happens at the transform stage. Repurposing second life batteries involves extending their utility beyond their initial application for other energy storage needs. The repurposing process is complex and requires different phases: testing and grading to determine their remaining capacity and state of health, disassembly and refurbishing, preparing the modules for new applications, combining modules to create larger storage units suitable for different purposes. Second life batteries can be used, for example, as stationary storage systems for renewable energies, for grid support, and to power EV charging stations. Concerning the enable stage, the criteria integrated in a tendering procedure can be applied according to different patterns: exclusion grounds, selection criteria, and award criteria. These have to be modulated, taking into account factors like the level of maturity of the supply chain, the bargaining power as a buyer, the critical mass of the procurement, and last but not least, the strategic relevance of circularity towards specific technical characteristics, sometimes quality of the solutions, and cost effectiveness. Thank you for your attention.